Welcome everybody. My name is Boldizsár. I'm from the Budapest University of Technology and Economics from the Crisis Lab. And welcome to all of you who are hardcore Hacktivity visitors and staying here for the last presentation. For this reason, I try to be more funny and a bit more interesting. So only half of my presentation is about this fact that the sample called BAB0, which corresponds to our anti-APT product test. And in the rest, I will talk about some other interesting items we worked on. So last year, just at the Hacktivity, we made an anti-APT product test. What was this all about? You all know the normal, regular antivirus products do not help to find all these kind of tricky threats like APTs, targeted attacks, zero-day vulnerabilities, and other stuff. So therefore, there is a range of new products provided by different vendors. And all these vendors say that, okay, hello, please buy our product and you will be saved and all your threats will be found and your system will be safe again and nobody can attack you, which is surely not true. And the list of the vendors is quite long. And all these products has fancy marketing material and so on, but what is the truth? If you really want to buy something for $1,000, you expect that the product should do really what it is intended to do, and you need some more information how good it is. So it is quite problematic to evaluate what to buy and say that, okay, is it good or not? Of course, at the end of my presentation, we say, buy all these products. Buy antivirus, use all these other products, but what we wanted to show is that maybe the marketing material is not enough and we need much more sophisticated testing and understanding how these products work and what are the problems they are protecting you against and what not. So there was also a controversial test by NSS Labs when the vendors were worrying, people were not really happy about the results. I mean, how the test was performed. And therefore, we found it to be a good idea last year to carry on a bit more advanced, interesting test on these products, as I mentioned, just at the Hacktivity. But at the end, we provided some feedback what happened, but not in details. And this presentation, the first part, is about the details, how, what is this particular sample and how we tricked products to get our attack going through. So we carried out this test with MRG Effitas and Crisis Lab together. So what we did is we developed 4 new custom samples. We call them samples. I can call them malware, but it is not malicious. I mean that what is malicious? What is transmitting information can be malicious if it is transmitting stolen information and not malicious if it is not. So it is not just based on the fact what it is. So the official name is sample, but of course you can translate it to some kind of experimental malware or something like that because the functions are really similar. So we created 4 different samples and we worked on that only for 2 weeks with a limited number of people. So we had no $1 million budget. We did not have staff working on that all night and day. It was a small scale attack. And of course, we try to make different samples with different things in mind. So we try to make sample that is quite easy to be found, and therefore we can test that all products really find these samples. And we also made the final, the biggest, the most interesting sample that should elaborate all our tricks that we could define in these 2 weeks and try that this should be really undetected by the products. And of course, for these tests, we made real malware-looking samples. I mean that if we make a program that does not make any kind of malicious behavior, or it does not run programs, it cannot be controlled remotely, and so on, it's pretty obvious that nobody will detect it. So what we did is really real-life like samples. And what we did is testing these samples on 5 different anti-APT products. All these products are network-based products, so like a proxy checking what is the traffic and doing something, not endpoint protection. So endpoint protection was off, no antivirus, nothing at all. This is important difference between normal stuff and real environment, but our focus was to test these products alone and not additional ones that can be combined with them. So the result, which we already presented, is detailed on this slide. Namely, we have these 4 test samples, and test 4 is called BAB0. And as you can see, all the 5 products were bypassed, so meaning that either there was no report or a slight notice, which is not really an alert message like you were infected, and it's most important to test your system right now. Okay. So what we did is later we shared the particular sample, the malware, malicious part, the executable part of the BAB0 sample. We waited some 2 months to people be prepared for introducing it, and we did not publish the CNC code, therefore it cannot be really used for malicious activities except if somebody makes the CNC server, but those who can make such kind of activity, they can surely make another malware, and it's not a big deal. Of course, it is because we are researchers on the defensive side and we don't want to help others how to attack systems, just to open the eye and show that we are vulnerable to similar attacks. So the sharing was through our blog site. You can find still there, even download the sample. But how this really looked and how it worked and what was the trick why no product detected it. The tricks are quite easy and not so sophisticated in advance. You will see it by yourself, and it does not take hours to give you the details. But that shows that even with these slight easy tricks, you can bypass these products. Then those guys who have a lot more time to design and a lot more budget to design their attack, it is surely not a big deal to find similar ideas during their activities. So, first of all, I have a video recording on how I installed this sample on the computer, and also part of it is how our dashboard or control panel look like when we can control the infected computer about the stuff. Okay. So, if you open up this web page, which is the infection web page. I first move the mouse, showing that the mouse icon is moving, and if I click here and there, then nothing happens. And even if I click on the download icon, nothing happens. So I will explain it, what is the reason behind that. Okay, I reloaded the page and clicked on the download button. And of course, as I mentioned, there is no checks, and the user is crazy and accepts this file to be run on the computer. And now our sample is running. Of course, we have a fancy notice that this is not, so to be the real users to notice that we have something, a problem here. So this is the command and control server dashboard for it. We have old data here, so we reinitialized the database, and so we have to wait a bit. Oh yeah, our client is reporting in. So I just change the session ID for the computer I want to control and send a task that please print the actual working directory. If you click on the view response, then at the response you can see it's my home directory actually. So I can even change directory for, let's say, this BAB0 directory. So just put change directory, the command is queued, and we can wait. We can even add additional comments, so it is not like these bad old control panels. This is a fancy, good control panel for our tests. So you can check the directory. There is a secret.txt file inside this directory. So now we click on download file, which will, a new task again, already completed. the file downloaded is renamed to file.bin, so I save it first into a directory called stolen, and I will show in file manager what is the content. So this is the directory stolen, and the file contains text, actually, because it was a text file, very secret, that they stored here. So we successfully stole information from the target server. This is the demonstration that this sample was really doing malicious stuff in that sense, that it has all the functions that a traditional remote access Trojan generally fulfills. We have other commands like execute shell command and things like that, but not really interesting. Of course, we can add new functionality or upload new modules, but it is not interesting from our point of view. As long as the network traffic is really looking like a normal RAT attack, and this demonstration about the file download has shown that it is really looking like that. So if you can download files and do similar things, then it is really close to what a normal malware used to do. Okay, so this is how it worked, and now I explain why this happened during the attack. So first of all, there is no download link on this web page at all. So this web page is a single image, a PNG file that has this download text embedded into the picture. So it is made by Photoshop or whatever, and the download icon is just a part of the picture, nothing else. If you click on any other place than the download link and the border drawn in the picture, then our JavaScript recognizes that somehow the user clicked on a bad point on the web page, not intended to click there. So maybe you have something like an analysis framework running and clicking on different parts of the web page. And that disables all the further activities. So if you clicked any other places on the web page than the download link, then the functionality is blocked and nothing will happen. So therefore, I had to reload the page after clicking several times. Who knows? We have no exact data how these products tested our solutions. So we don't know if this trick was important or not at all. But this was just a good idea to include. So when I moved the icon, the mouse pointer to the download link, then we had this new icon, the hand icon. And as I mentioned, there is no link on this page at all. Then how it can be possible? It is emulated by JavaScript. Whenever you move your icon to the target area, then we show you the hand icon instead of the normal icons. So the other trick is there is no executable transfer on the wire. So the products could not see any executable downloaded from our servers because there is no executable at all. When we clicked on the download icon, basically what happened is that we had some JavaScript code that actually extracted stegonographically encoded information from this picture, which was the malware itself, the executable. And the JavaScript was able to emulate you that when you clicked on that, it is exactly looking like, I will show you, on the right-hand side, you can see that, okay, do you want to run this program, this executable? So from the user perspective, it looks really like not downloading an executable. But from the network point of view, it was just a picture that was loaded already at the starting of this whole stuff. So there is no transmission during you click on the download button and so on. And below, you can see the actual contents of the directory. So what we had is really just a picture, an HTML file, and two JavaScript libraries, and one style sheet stuff. So that's all. On the server side, it is totally static. We can recheck. So what happened now, as you understand the whole stuff, so when I move the mouse, nothing happens. If I move it over to the download link, then you can see the mouse icon making a difference. If I click here and there, then we have a problem because the malware is deactivated. So we have to reload the whole stuff to be able to click on the download icon. This click does not mean anything. You can see it in an executable file. Do you want to run it? Is in Hungarian. Nobody knows the vendor of this software, so are you sure you want to run? Yes, I want. And then the sample is downloaded and is running in this window. And it works. So yesterday I tested it again. It works on Internet Explorer and also in Chrome. So it is not a very specific feature of a browser. Yeah. So on the client side, there was no endpoint protection, as I mentioned. Therefore, all these malicious activities that can be found by anomaly detection or any traditional, let's say traditional means like finding out that there is strange behavior because somebody is running executables, there is a new process running, the process lists files, reads files, executes commands, and generates network traffic. This is simply not monitored. So whoever extends the functionality of the protection, of course, maybe it can be detected. But of course, real-life attackers can do other tricks to avoid this kind of detections, like rootkit stuff or zero-day exploit, whatever. The next big question is then, okay, installation is very hard to detect by these products, but what about the network connectivity? So how can we put all this information, the commands we send to the victims and the information that will be downloaded from the victims into a network traffic that will be analyzed by these devices, and maybe it will show that these are suspicious. And today we already had a presentation about finding out strange stuff in network traffic, where actually Sebastian also shown that they were detect the BAB0 communication traffic at some sort, but so check that presentation as well. So what we did is we created a small proxy server in PHP that basically passes all the requests that comes to a particular directory called forum to a real remote server containing real forum discussions, lot of different topics, lot of users, banners, whatever, registration, feedback form, I don't know what. So we just put all the queries coming to us to this real endpoint, and we were just a proxy. Of course, we modified the layout a bit. Just first of all, whenever we demonstrate it, do not show the actual company who has this forum. It was a normal Hungarian website containing a forum. And also, if any of these products checks something or any human checks if this forum is valid, they will see that, okay, there are a lot of messages inside, so it looks really valid, but there are no big titles that the web page is actually not here but there, so no hint that this is a fake web page and not a real one. So even if a human is involved in the checking of the validity of the web page, they will see, oh, it's a strange forum, I never heard about that, but it contains a lot of thousands and millions of messages, so it might be okay. So why we created this proxy is because we put all the communication hidden into the downloading of different messages from this forum. For not to be suspicious so much, we divided bigger commands or big transfers into fragments. And then we try to recover from all these fragments the whole command or whole data that was submitted. If it was even more in length, I mean a big file was transferred from the client, it could, we also use the trick to embed that stolen information into a picture, which is uploaded to some website on the forum, which is again not that suspicious. Everybody uploads pictures about cats to forums and so on. So basically that is one way. On the other, we just added small items like an additional cookie, like we abused the PHP session ID cookie to store particular identifier. Most likely it cannot be seen. This is an Apache log about the activity what our client made. So basically what BAB0 did is that clicking here, clicking there, moving from one forum to the other, randomly downloading, and only small snippets of information is embedded into cookies, and sometimes bigger, if more data is transferred, then it downloaded by a picture or uploaded by a picture or something like that. So, of course, this can be found by a number of means, like who is clicking 24 hours a day on forum messages and not waiting a single minute. So it was, of course, suspicious, but we expected that these products most likely are unable to differentiate between automated process like Skype talking with hundreds of different parties and somebody who is using a forum. They are not concentrating to finding anomalies by like that, but it is not impossible to do something on it. So again, this is a TCP dump like stuff about how the identifier was transmitted. So that's all basically. No big trick. So small items combined together and the product was bypassed. No executable, we used steganography multiple times, only activated the stuff if the user is bad enough. I mean that we tricked him to run the program from a vendor that is not known. It is hard to detect the installation, as I mentioned, because of the lack of any executable and any traces that this is something tricky. And the communication is also problematic to be found, the malicious, because it is like a normal-looking traffic. And and of course, I have to add that this test was done on one of our websites, which has a good reputation, so nobody can say, okay, this is a hacked website or a rogue website somewhere, and we already know about that. So therefore, I think that these products had really a slow chance to catch these type of attacks. And if they would indicate that this is suspicious, then you will surely get hundreds of thousands of alert messages daily, and because of normal traffic can be such suspicious as our traffic, and hence the product would be just impossible to use. So this was about BAB0, and I have more than 20 minutes left. And what I expect, when I made these slides, I expected that I can finish it so shortly, and that means that I don't want to be slowed down and tell you all the details and so on, which is not quite interesting. Rather than I could add some other information or other things I can talk about and belongs to our work in the recent months or 1 year. And one particular interesting thing was Duku2. I was talking about that at ITBM, but ITBM presentation was in Hungarian, so for all the visitors or all the others who are checking later on YouTube my presentation, it's easier to them to get it in English, but I will be a bit shorter. So as you know, we were quite active in the field of uncovering or technically analyzing targeted attacks like the Duku, the malware that we found in 2011, and which is most likely done by the same guys who created Stuxnet, and I don't have to introduce Stuxnet right now. Then on Flame, Miniduke, TeamSpy, and several others more or less. But one interesting question, what happened in the last year? A lot of other pieces of malware were uncovered, like the NSA ones called Equation Group or Regin. We already had a presentation about some details of it and so on. So a lot of new discoveries for sure. But the other interesting fact is that this is the year when we see the already uncovered missions to continue their efforts. So nobody knew what will happen after we find Duku, find Flame, whatever, but now we see something about the next steps. Like for Duku, Duku was active again as Duku 2.0, I will talk about that. Flame might be extinct, but Flame infected 10,000 of hosts in the Middle East mainly, and one reason behind that was possibly, who knows, that the attacker already knew that some other stakeholders knew about the attack, so it was already found that it is no good anymore, and they infected as a last wave of attack or something, considering that, okay, somebody will find this attack, but we won't use it anymore. So most, who knows, maybe extinct, maybe they will come back. For mini-duke attackers, they continued their attacks, and Secure published a quite interesting paper about all the activity that can belong to the Duke family, because it is not just mini-duke, but onion duke, cozy duke, and all the other dukes together. So check that report. And also on Team Spy, you can check the Dumble report, because the attackers are still active. So even after they have been detected and they have been analyzed and shown that these are targeted attack groups, because some of the samples always happen to be detected on VirusTotal, but not necessarily means that there is a report that there is this active group doing attacks. So after these type of reports, they are still active. Of course, that's not something surprising, but nobody knew how it will happen, what will be the next step for these guys. So for Duku 2, the last original Duku sample was in February 2012, not only a few months after Duku, and then we saw no sample that was really belonging to the Duku attack. But Kaspersky this year, in early summer, revealed information that they have been attacked by the Duku 2. So the victim was the Kaspersky lab itself, which is, as you know, one of the biggest antivirus vendors, which is quite frustrating, because most likely the case is not that this company absolutely has no idea about security. The case is that even big companies like Kaspersky cannot protect themselves, and that we have to say that and admit that yes, the attackers are always inside. The perimeter defense does not work, so Kaspersky can be happy that they were able to find the attack traces for the attack possibly months later, but still they were able to recover in some sense. And officially statement was that they used a prototype anti-APT system inside Kaspersky, and they found the traces by this new product. I'm really interested what can be this prototype stuff. The attacking it was important enough. Somebody really attacking an antivirus company is taking a big risk. So it's easy to get caught. So it's not that easy. But again, just like in the original Duku case, we have something that shows that it might be related to the Iran nuclear talks, which happened throughout the year and so on. And also the zero-day exploits emphasize the thing that these guys are sophisticated again. But I said that it's Duku 2, but why should, I did not explain why should we think that it is related to the original Duku attack. Maybe it is sophisticated enough, but maybe by other state and other threat actor. That was the question. Actually, we have been contacted by Kaspersky, and the question was like, they think that they found a module that is really similar to the old Duku samples, and what do you think? And we are frustrated, because if we will reveal the details about this attack at the newspapers, maybe the newspapers will also come to us and say, maybe it is not related to the Duku attack. So what about for the Crisis Lab helping us in that manner, so doing some objective, I mean not biased analysis showing if the sample is related to Duku or not at all. For Duku 2, they have new ideas. It is highly modular. Modules are generally in the memory and no hard disk presence. So if you shut down a computer and take it home with you, most likely you will be unable to find any traces on the computer that this computer was hacked or used by the Duku. That also means that if even the main module is not installed on the computer, then there is no persistence at all. So if you turn the computer off and on again, there will be no malware on it, which is quite frustrating for those who analyze this computer, but good for the attackers, because if in real-life environment, in a big company, most of the servers running constantly 24 hours a day or something. Sometimes they're restarting them, but it is quite unusual to have all the computers turned off. So even if only one computer remains infected in the network, maybe they can go back and infect the other computers, especially if they have 0 days that are compatible with network stacks, or like remote exploitation or something like that. So it's tricky and risky and needs a lot of work, but it's really hard for the good guys on the defense side to find this stuff. And there was some deception also in the attack. The Kaspersky found something like 100 different modules, and some of the modules looked like modules from other APT attacks, and that can lead that, okay, if we check only one module, we could say, okay, this is a Chinese attack because this module is generally used in Chinese attacks. But one of the most interesting part was this main module of the Duku2, what we analyzed to show that it had similarities. So I will talk about similarities, and we found some interesting similarities, but there were also differences. So it really looked like the Duku2 main module was redesigned in that sense that to remove all kinds of possible detections from all the reports originally made. So like for Stuxnet and Duku, there were a number of magic numbers inside, and people were talking about, for example, you see this number like AE 240682. It can be a date, and what happened on that date? Maybe the birthday of some developer, maybe some other event in the Middle East, who knows? And this was, of course, interesting to the press itself. For the Duku2 samples, we don't see such magic strings. They look like random, so all kind of information like that was removed. And there were several others, like all the other things that was supposed to work to detect Duku original version are generally not working against the new one. But there are also similarities, and one important similarity is the C++ style language that they use. So it is not real C++. Kaspersky made a long discussion about that, and it was even criticized because nobody exactly knows how Duku is programmed. It looks like it is normal C code, but it is object-oriented. But there are some differences on the binary code when you see it, like virtual function tables are a different position and so on. And it remained the same for the new Duku attack. Of course, alone, this is not a proof about the connection between these two things. And of course, they use the new compiler versions and linker versions sometimes. And that also makes differences in the actual binary code, but still there are similarities. Just some direct samples what kind of other similarities we could find. There is a string decryptor routine which is normal for all malware. I mean that they want to hide some of their strings because it would be obvious if somebody looks on the binary and it contains download all files or something like that that is malicious. So they generally encrypt the strings by not cryptographic grade encryption, but something a tricky XOR or something. And for the Duku2, you can see this encryption routine on the strings, which is a simple XOR, but 32 bits each round. But 32 bits, but you see the repetition of the actual magic number, which is 86F1, 86F1. If you look on the original Duku string decryption, it is almost the same. The code structure is a bit different, but they also use this trick, but with B3, 1F, B3, 1F. Again, this is not a proof. I cannot prove a relationship between two pieces of code because it is almost impossible. But all these small hints together conclude with the fact what was the target, how it was attacked, the 0 days, and so on. So all together show us that it is most likely the same guys. One other interesting point was the AES encryption code that was embedded in the code. In addition to the AES, I think the init vector was modified by an XOR with a magic string. So on the left-hand side, you can see this dead BAB hexadecimal string that was used in the original Duku code. And now we have quite similar implementation, and the same XOR technique, but the magic number is now seemingly random. Which is strange in that perspective. I already mentioned you that there were a lot of hints in the press and reports what kind of magics have been put in the Duku. But I found that this dead BAB was never published. So I looked during our analysis on Google, and I found no Duku paper explaining that at the AES there was a string like dead BAB. But still, the developers removed and changed it because it was like, okay, you have to change all these strings and not just those that was already discussed or analyzed. Okay, again, it is not a proof, just a slight thing. But there was one other problem. So both in Duku 1 and Duku 2, there was this AES routine used in a special crypto mode, which is not exactly CBC or something. It is similar to some standard crypto modes, but not fully exactly the same as others. This is depicted here. So the thing is how one packet is coming after the other, but the question is how the final packet is padded to be a complete block, because it is AES is a block cipher. And the problem is that my guys found in the code that if the message is smaller than one block, so like smaller than 16 bytes, then a buffer overflow can occur here somewhere. I don't even see my slides so much in detail, but you can possibly find it. So the trick is that if the message is too small, then this, the block before does not contain any data, and therefore it will be badly used, and maybe even the process crashes. Which is quite unusual to have this kind of bug, because if this AES routine is a traditional crypto library, then anybody who will use it on short messages will instantly get some errors and some hangs, and will notify the author of the library, and it will be fixed. But in this case, when it was possibly implemented only for the case of Duku, then it might never be tested in short messages, because they use it in a particular communication when they always send more information than one block only. So, of course, there were no details about this problem for Duku 1 in the former reports, but now we see that this implementation is quite similar. This is how it looks in the stuff. There are some additional identifiers. I don't waste time on that. Also, very interesting is the logging routines. They have a lot of logging magics put in the different parts of the code. So like if I open a file, then I call the logger subroutine with a special magic ID that it is file open happened. And this magic ID is stored in the logs that I don't know at what date file opening started, but it was unsuccessful or something like that. And this is again a comparison of the original Duku and the second one from an IDA Pro output showing that how these log routines are exactly called, and even the number of the different calls for these log entry stuff are very similar. The signatures, these magic numbers, are exactly the same for both attacks. For communication, we also have some similarities, but for example, the original Duku abused a JPEG file for hiding information. So there was a small JPEG file, and additional encrypted information was transmitted after the HTTP transmission of the original file. Here they used GIF for transmission. And for the original one, they used PHP session ID for transmitting some identifier, like we did in BAB0, and only one user agent string. Now they modified it. They take it from a number of agent strings, and then they don't use PHP session ID. We will see instead they use a new cookie called country for this transmission, and the GIF file does not have a fixed name like for the JPEG file. It was fixed like dsc0001.jpg. Now the GIF file contains random numbers as well. This is the list in the code about the agent strings, and some like here is this DSC from the Duku, the original Duku stuff. Now we have the similar stuff in Duku 2, including the GIF file name, like you see the %05d.gif and the country cookie. And here the original Duku containing a PHP session ID. So there are possibly a lot of other stuff. We had a report about that, and it is on the web, so you can check it by yourself. But the conclusion is that we are pretty confident that most likely the guys behind the Duku 2 attacks are the same as for Duku 1. And now you see why. not a single fact alone, but the long list of similarities and the style and sophistication. I mean that even if it was not done by the same guys, they surely have similar amount of money to make all the environment or the 0 days and so on. So it is surely not some garage operation or something. So it's surely a sophisticated attack, but most likely it is done by the same guys. And the last topic I want to talk about today is Roscoe, or a system which we presented, for example, recently last week at the Virus Balloting Conference in Prague. So it is called Repository of Signed Code. The importance of this is a quite interesting stuff, and the novel thing is that now you can use it by yourself. So registration is open, and you can test if it helps your research in any kind, in any means, and you can send some feedback to us as well, how to improve the system. So what is it all about? So the motivation is that digital signatures are more and more used in our computing environment, and therefore attackers, the APT attackers as well, should sign their code more and more, like all these APKs or Android applications are generally signed, Windows binaries should be signed, Windows drivers should be signed, and therefore the attackers will also use the digital signatures and abuse digital signatures and all the infrastructure. So we already saw that this happened quite a number of times. First pieces were like Stuxnet and Duku. One of the similarities was that for Stuxnet they abused a kernel driver was signed by the key of a Taiwanese hardware manufacturer. There was another piece of this kernel driver that was also signed by other Taiwanese manufacturer, and for a long time it was attributed to Stuxnet, but now there was some leaked information, debates about that possibly there was another Stuxnet attack against North Korea, and for the different kernel driver might have been used in North Korea. It was uploaded to VirusTotal later on from China, but it might be the trace that they really had this attack against North Korea, and people say that it was unsuccessful attack against them, but who knows the truth. But so there was these two samples of digitally signed and abused code in APT attacks, and then when we found Duku, it also abused the digital signatures because another Taiwanese manufacturer's key was used to sign the kernel driver of Duku. And now for Duku 2 we also have some digitally signed code in that. So, and of course, later on, I don't say we have hundreds of samples, but possibly even, yes, hundreds of samples that in those cases, targeted attackers took a private key of one vendor and attacked by other vendor based on the key or certificate they stole from the former. So, our idea was to develop a large repository of signed objects, so something like VirusTotal containing all the malware. We want to collect all kind of information about digital signatures, mainly related to the code, but possibly also related to SSL communications like X509 certificates. We of course possibly not store the executables themselves, but at least we have information about the source of the executable, the hash of the executable, and similar. We also extend this functionality, this database, to store information about Java files like jars or APK files, and to provide basic services like you can check information about a particular sample. If anybody else uploaded it, saw it, information was retrieved on it, or other things. And with this system we can make more advanced things like adding alert functionalities that, for example, a developer will be notified if any code is found on the internet that was signed by his or her key. And he can check if it is originating from him or somebody stole the key and using it for malicious activities. So with this in mind, we created a prototype system, which is Roscoe, which is based on Hadoop HB's database, so big data thing, because we need to store a lot of information and efficiently retrieve them when the user needs it. We also made this alert engine and the web-based interface with graph view and other stuff, how you can possibly do research on different things. Like I found this, what is the relationship with this and the vendor who created it, what did the other vendor, what other codes so what other codes have been cited by the same vendor and other type of stuff. As I mentioned, we already collected a lot of information, but we should extend this if it is possible. We already used up data that was available on the internet, like the SSL Observatory data on X509 certificates, but we also added the results for own ZMAP scans on the internet. We have some crawlers to get information on executables and other files. To show you why it is important or why it is usable, and I just show you a small example which is quite tricky and really demonstrates the power behind the idea. So we found in some case, I don't know what reason, an APK file that was signed by a guy called Ivan. So the certificate says that it is signed by Ivan, and we don't know exactly what Ivan. So we go to VirusTotal and check what the database knows about that, what other antivirus engines say, is it malicious or is it not? And the result was at that time that VirusTotal said that only one antivirus takes it suspicious or malicious. All the other antivirus, the 46 other, said that it is a clean file. Okay, great, then I can install it on my phone. Or wait a minute, so what can we do? What else can we do? Okay, we know that this malware is signed by Ivan, or this sample is signed by Ivan. So let's ask the Roscoe database, do we have any information on any code that was signed by the same key? Not possibly the same name, because Ivan can have, a lot of Ivans can have different public keys, but you can also extract the public key and look for the particular public key in our database. And what we found is, yeah, we have information about a number of applications, especially APK applications, Android applications that was signed by the same key, by Ivan. So let's go back to VirusTotal and ask VirusTotal about these other pieces of code. And VirusTotal tells you, okay, more than 20 different antivirus vendors say that it is suspicious or malicious, and only half of the antivirus products say that it is not, which is quite normal. I mean that some of the antivirus products are not good enough to detect all kind of samples, but that's yeah, that really showing us that this should be malicious. I mean, if all these code are malicious, then most likely the one which we started the investigation with is also malicious. And hence, traditional antivirus could not help you, but our Roscoe system could help you to find out more about the thing and protect yourself. And basically, I don't tell you this one because I reached the end of my presentation in time. So if you want to sign up, please use roscoe.crisis.hu or crisis.hu for signing and checking this system. Thank you very much.